So today, I think I will be teaching you starting from the mean and the variance only. So in E-maths, of course, you know what is mean already, right? Only need to revise about variance. Mean is average. So variance, the formula is given by sigma x squared over n minus x bar squared. So what is sigma x squared? So sigma notations, right? Sigma means the sum. So when I say sigma x squared, it means you need to square the x1 by 1 or the data 1 by 1, and then you add them up all together. That's what sigma x squared means. Any questions until here? So for the group data, for example, now we have data. We say this is a score. And we say like let's say 60 to 70. Then we have 70 to 80. And let's say the frequency is 5 and 4. So if you want to find the mean and the variance, you have to add the mid value first, which we already learned in E-maths also. So the mid value is 65 and the mid value is 75. So if you want to find the x bar, it will be as simple as 65 times 5 plus 75 times 5 divided by 9.
So not times 4, sir. 75
Sorry.
times 4.
75 times 4. Okay. Divided by 9. So we have 69.4. Yeah, I think that here is still good, right? Now, I just want to explain about the variance actually. You want to take picture of this before I continue? Yeah, continue, yeah. And so, when you want to find the variance, you already have the formula just now, right? When I say sigma x squared, it means the x right now is 65. The x that you are using is 65, but how many 65 are there?
5.
5. So means it will be the 65 you square x squared, right? So 65 squared, and you have to do it for 5 times. So 65 squared plus 65 squared plus 65 squared 5 times. So I just write times 5. Then added with your 75, you have to square also. How many times are there?
4.
4. Then we count. So 65 squared times 5 plus 75 squared times 4. So 43,625. So after the variance, sigma x squared, so 43,625 divided by 9 minus with your x bar squared. So the answer will be 30.87. Any questions until here? You understand? This actually you have learned in E-maths. So do you understand before I continue? No questions. Okay. So I clear the board here.
Sir, the X with the line on the top, what is it called?
The x, the line on the top. X bar. We read it as x bar is average.
Okay.
Clear the board, yeah. But that is just an introduction. That's actually what you learn in EMATS. What I want to teach you, what you want to learn in statistics, right? It's not that. Yeah, but somehow I still need that. Somehow I still need. For those who just come in, right? We just revise about the how to find the mean and the variance. Right? Okay, later I will. This one I still continue teaching. So now it's more important again. Later overall, I will upload the video also. So if you want to rewatch or restudy, you can watch from there. Okay. Now, let's say you have a set of data. You have a set of data, and the data is either being lowered by A or increased by A. How will this affect the mean or the variance? Okay. Before we talk about increasing or decreasing, the question is why? Why you have to increase or decrease the data by a value? So to simplify the calculation, we have to do that. So imagine you have a case like, let's say you collect the data, you have the height, measure in centimeter. The height is 170, then you have a 172, then you have a 174, and you have 175, and you want to find the average. If you only have 4 data, it won't be a problem. If you have 1,000 data, also it won't be a problem because however you can use calculator, you can use Microsoft Excel to find the average. But the problem is when you type it, you have too many digits, it can be a mistake. When you type in your calculator, it can be a mistake. So right, this data, I can, if those who understand statistics, he for sure will lower it by 170. So he will change it to 0, and next one will be 2, next one will be 4, and next one will be 5. He will deduct this by 170 to make the calculation easier. But then the problem is if you deduct it by 170, what will happen to the mean? I want to derive formula because I don't want you to memorize the formula. Okay. So now let's say original situation there. I call this data as x here. So now I lower it by a. So means when I say sigma x, the notation will be sigma x minus a in bracket. Why? Sigma means sum. So the data has been lowered by a. All of the data have been lowered by a, and then you add it. So it means if I write sigma x minus a, it means x1 minus a added with x2 minus a. I add until the last x minus a. You understand until here? So when I find the x bar right now, the second x bar as in like the one that I lower the data by a, the notation will be sum of the x after I lower by a that I divide by n. Still understand until here? Okay, then since your sigma x minus a is related to x1, x2 until xn, means I can group the x1 added with x2 until xn, right? Do you understand here? Then how many a are there?
NA.
NA. Gabriel mentioned NA. Do you guys understand NA?
I don't really understand, sir.
Because your x1 you minus with a, your x2 you minus with a, your x3 you minus with a. So you always minus it with a. For how many times you do this? up to xn. Up to xn. So means you do it for n times. That's why Gervin just now mentioned you have NA. Because you have n data and all of them you minus it with A. So means you do it for n times. Equation here. Then the fraction I can separate become over n over n. Okay, you want to take picture of the board before I continue? So I'm deriving the relation here. And so you have the sum of x1 to xn, right? Means you can change the notation. So the x bar 2 right now, I can change the notation becomes sigma x over n, right? Sigma is sum. So sum of the x is sigma x over n minus, cancels out, minus what? A. Sigma x over n is also an average, your original average. So after you lower the data by n, your second average is equals to your first average lower by a also. So what is the conclusion? The conclusion is average always follow what you do. So you go back to these questions. Let's say you have 0, 2, 4, and 5. If I ask you to find the average, how much the average will be? Means you answer like 0 plus 2 plus 4 plus 5. So how much do you get? 11 over 4. Right? That's the average that you have, right? So 11 over 4 is equals to 2.75. So why you get this 2.75? You get this 2.75 because you have lowered the data by what? Because you have lowered the data by 170, right? So what is your original x bar?
172.
172.5, 175. That's what I mean by you can do the calculation easier. So x bar always follow what we do. So if you lower the data by 170, it means your original x bar is 170 more than that. Any questions? You gonna take which of the board again? Okay. Now we go another example. Still about x bar. I don't rush to for answers. You learn slowly, but make sure you understand. Okay, so let's say he wants you to calculate the sigma x minus a. Then he tell you the initial average is 42, and the final average after you lower by a is 4. So the n is 10. So how much is the difference? The difference is how many? Between 42 and 4. The difference between the x bar 1 and x bar 2 is 38. You understand over here? So yeah, let's say the question asks you to find the A. So it means yeah, if you are asked to find the A, it means the A is like you lower it by how much? Yeah? So your difference is 38, right? It means the A is equals to
38.
the A is equals to 38. So let's say if the question asks you to find the sigma x minus A, then you have to use the second x bar. So your second x bar is equals to the sigma x minus A over n. Right? So the second x bar is a 4. Then your n is a 10. So your sigma x minus A is equals to 40. So you have to use the second x bar to solve the sigma x minus A. Any questions until here?
So the 40 from where?
The 40, 4 times 10. The second x bar now is only leaving a 4. So
Okay.
any question again?
We want to find the A, right?
Yeah, so the A is just 42 minus 4 is just a 38. The A get ready from the beginnings because the difference is only 38. No questions. Okay, now I want to derive the variance here. So just now, we lower the data by A, right? What will happen to the variance? So the variance formula is variance 1 is before you lower it. So it's a sigma x squared over n, right? Minus x bar 1 squared, right? Now, the data has been lowered by A. So means my second x bar is what? My second x bar, because you have learned already, if you lower the data by A, it means your second x bar is equal to the first x bar subtracted by A. So the average of the x bar follow what we did. Now the sigma x squared have to change the notations already. It becomes sigma x minus A squared. What does it mean? It means each of the x you minus with A, then you square. And you add it until xn minus A squared. Now we discuss slowly first. X minus A squared is what? X minus A, x1 minus A squared, if you expand it, like you write two bracket and you expand your E maths only. So it's a x1 squared minus 2ax1 plus A squared. Then you have until xn minus A squared. So means you have xn squared minus 2axn plus A squared. And then you have to add this all together. Any questions until here? So when you add the x1 and the xn squared, this notation, I can call it as a sigma x squared. Because it's a normal x squared being added, so it's a sigma x squared. The second group, I can take out the negative 2a, can factorize, leaving what? Leaving x1 added until xn. You understand? And the last group is what? The last group is a squared, right? You add it for how many times? n times, right? So plus what again? Plus n times what? A squared. Until here, do you have any questions? No. You want to take whichever version before you clear the board. So now, pay attention to the formula. Yeah? I am explaining this for you. I'm just explaining the sigma x minus a squared. So means whatever that I get at here, I have to replace it right with this, right? I have to divide by n again. So means right when I want to find the variance too, this now I get a sigma x minus a because I lower by a minus with a x bar 2 square. So your sigma x minus a square is sigma x square. Just now you're understanding, you say you understand already, eh? Minus 2a. So 2a x1 plus until xn, right? X1 plus until xn is a sigma x, isn't it? X1 plus until xn is a sigma x, right? And you have what again? Plus n times what? A square, right? Then you have over n, over n, over n, right?
So from where you suddenly get 2ax and sigma x again?
So before I clear this just now, I take out the negative 2a already, right? And I have x1 plus until xn. So x1 plus until xn is sigma x at the notation. X1 plus until xn is sigma x, sum of x. Understand? So I cancel out, yeah? So leaving the plus n. So you see this? Sigma x over n. What is sigma x squared over n? Sigma x squared over n is it? X bar, right? Average, right? Original average, right? You understand what I'm doing here? Plus plus a square, right? So I have the minus with x bar 2 square, right? What is x bar 2 square? X bar 2 square is your x bar 1 minus what? A in bracket square. This is also x bar 1, right? Now, I have to factorize, I have to expand the bracket. So if I expand the bracket, it give me an x bar 1 square minus 2a x bar 1 plus a square. Now, yeah, if you want to understand the derivation, yeah, good. If no, you just take the conclusion. A square minus a square, gone. Negative 2ax1 square, so no squares, right? Negative 2ax1 and negative 2ax1, what happened? Also gone. So leaving what? Leaving sigma x squared minus x bar 1 square, right? Sigma x squared minus x bar 1 square is also a variance formula, right? Which variance is this? Your original variance, right? Your sigma x squared over n minus x bar 1 square, that's your original variance, right? The variance one that I read in the first place just now. You want to take a picture of this? So what is the conclusion set here? The conclusion is, when you lower the data by A, the mean will follow. But will the variance change? If you only plus or minus the data with A, right? The variance 1 and the variance 2 will stay the same. Now we go back to the question just now. So I have a 170, 172, right? 174 and 175, is it? If I'm mistaken. And then I ask you to minus it with 170, right? So you have 0, 2, and so based on the derivation just now, we have x bar 1 is 172.75. X bar 2 is 2.75, right? Try to find the variance first. Variance 1 and variance 2. Then you see if it's the same or not. So the variance formula just now I write again, is sigma x squared over n, right? Minus x bar squared. The x just now is given by 170, 172, 174, and 175 here. So now I want you to try. You find the variance 1 and the variance 2. So the variance 1, when I say sigma x squared, it means you have to square the x1 by 1. So 170 squared plus 172 squared plus 174 squared plus 175 squared divided by 4 minus with the x bar.
Sir, for x2, is that 2.75 or 2075?
2.75. Then later you'll find the second variance, your sigma x squared. You may not use 170 yet, because you lower it by 170 already. So means your second data is what? 0, 2, now what else again? 4 and 5, right? So later you sub in the x as 0, 2, 4, and 5, you count the sigma x squared. The second x bar, you cannot use 172 here. So you have to be consistent. So your second x bar is what? 2.75 squared, okay? I'll give you 5 minutes to 10 minutes, right? You write down, you try to confirm this if it's the same or not, okay? I come back one again. So I want you to try to do this and see if it's the same or not. You already have the question? Should I share the board one more time again?
Yes, sir. Share the board one more time.
Yes, sir.
Okay. So I'm about to let you prove by yourself if the variance is the same or not, like what we derived just now. You can move your down. You can move the note downwards and underneath.